All right, everyone, we're going to get started with, I think, what's the final leg or the final stretch of this locomotion system. We're going to be starting the task of wrapping this up and getting prepared for all the new features that have come out with 5.4. So I have a project here that I've almost fully developed, and the biggest added feature here that I really want to cover in the next few videos, maybe this one if I'm able to record it all in a timely manner, is an overlay system similar to the one that we've seen in the Advanced Locomotion System version 4. And that camera not moving is a bit of a glitch there. I'll have to figure that out. But as you can see, if I press a button here, the character transitions into playing an animation where a rifle is being held. There's no rifle because thus far I've only just focused on the animation end of things here. But as you can see, we're preserving some of that upper body movement into the arms, and we're using two-hand IK to get the left hand to follow the right hand around. The cool thing about this layering system is that I've developed it so that either hand can be designated as the dominant hand through animation curves. So if we want the right hand to be attached to a weapon following the left hand's movement, we can do that as well. And we can also turn off the layering on an individual arm. It's not as complex as the Advanced Locomotion System layering system in that we don't layer onto the legs, but we do have control over both arms and an additive being applied to the torso. I've also added aim offset support for turning, for looking all the way around. The turn in place I've disabled just to show this off. But of course the turn in place would activate a little bit sooner as we turn all the way around so that we don't get that switch around that is too fast. So in this video, we're just going to dive in and get started. And after I record, I'll figure out a good way to segment things into videos and title them. And you've probably already seen whatever we'll be covering from the title of this video. So to begin, we're going to start with the actual layering system itself. I'm going to go ahead and make my way into the base animation blueprint and into its main animation graph. Here we have what's essentially our finalized locomotion pose after our full body additives. I'm going to create some space between this layered blend per bone and this dead blending node. I'm going to go ahead and now create a new animation layer. I'm not going to be using an interface, and while I could put this layer into another animation blueprint, I tried that and I'd run into issues where we're trying to use linked layers from two separate blueprints. The locomotion layers, and in this case, an overlay layers blueprint. And that if we designate those on begin play in our character blueprint, depending on the order that they're designated in and when they're loaded, we can cause essentially a crash. And I've not figured out a good way to determine the sequencing of all of that yet, so we're just going to build out our logic in the main animation blueprint. I'm going to create a layer and I'm going to name it Overlay Blending. And we're going to create 3 input poses. And I'm going to do my best to explain how this works as I built it out, and it'll be much easier to explain while I do that than it will be to try to explain how this is all going to work before I get started. So don't worry, I will explain how everything works, but I just want to be able to kind of show you guys the nodes and how it's put together as I explain. So 3 input poses. I'm going to name the first one Base Pose. The second one, Locomotion. And the third one, Overlay Pose. And I'm going to go ahead and back out into the main animation graph for now and grab our new overlay blending layer. I'm going to input our layered blend per bone output pose into the locomotion slot on our new overlay blending layer and plug the output of our overlay blending into this dead blending node here. Now, what are these three input poses and what is their function? Well, the locomotion pose is fairly obvious. This is where we take in all of our locomotion animation, everything that we're going to be processing through IK after this blending. The base pose and overlay pose inputs are less obvious. The principle of this overlay system is that we take this locomotion and we make it an additive relative to the base pose. And what that means is we input a base pose, which would just be the character standing still in an upright position, and we look at the difference between the base pose and the locomotion pose, and we apply that difference to an overlay pose. Now, this is very effective for changing things like the posture of a character. If you'd like to change the angling of the arms or add a hunch in the back, you can create a hunchback overlay pose and apply the locomotion to it as an additive, and it's pretty versatile. And I'll try and show some examples once we have the rest of this system here put together. So we need a base pose. Now I'm going to provide a base pose asset in the description, but I want to show you guys how I would go about quickly creating a base pose or any other pose to use in this overlay system. Of course, what I've described so far only handles overlays and doesn't handle overrides. And I will get to that eventually, where we might want to override an arm so that it holds a weapon, such as a gun, still, while the character runs around and does other things so that it's not swinging the arm around. So we will get to that, don't worry. Back in a level, it can be any level, I'm going to go ahead and add a level sequence. And I'm not going to worry about naming this right now because I don't plan to keep this level sequence. I plan to use it and delete it. It might be a bit better to be a bit more organized than I'm being, but it's fine for now. So with this level sequence open, I'm going to go ahead and grab the mannequin skeletal mesh. And I'm going to drag it into the sequencer. And when I drag it into the sequencer, Unreal Engine knows to give us a control rig for this mesh, which will allow us to animate it. So I'm just going to make some adjustments to get the pose that I would like to have. And I think this is good for a base pose. So I'm going to select our control rig and add this plus button here to keyframe all of our controls. And now if I right click on this mannequin, I can bake an animation sequence from the control rig animation that we've created in the sequencer. So I will go ahead and do that. And for now, I'm going to toss this into the animations folder, and we'll go ahead and organize from the contents browser afterwards. But I'm going to name this OV for overlay. Well, AN_OV, so animation overlay base pose. And I'll click OK. And now, if I navigate into that animations folder, here we go. This is our overlay base pose animation, and it is quite long. I could have moved this to make it a single frame before, but I forgot to do that. So I'll right click in the timeline and just remove frame 32 to 151. That's not the slowdown. I want to get down to frame 1. So I'm just going to keep clicking and repeating that process, and there we go. It's not super accurate when it comes to where you click and removing the right frames. I'm not sure why that is, but now we have a single frame animation. So I'm going to close out of our sequencer as we no longer need it, delete this skeletal mesh, and delete our level sequence. As for now, we are finished with that. For this base pose here, I'm going to right click and get a sequence player. So I'll go ahead and search play an_ov and grab our base pose. And I'm going to convert this to a single frame animation and plug this in. So now we have a sequence evaluator, and I'm just hard coding this for now. But if you were to have crouching, you'd want to have a base pose for crouching and to switch between the two of these, because a crouching locomotion set would of course be very different than a standing locomotion set, and there'd be a huge difference between the locomotion and the base pose when we're creating that additive, and so it wouldn't apply correctly to the overlay pose. So now that we have a base pose and a locomotion pose, we need an overlay pose. And maybe I deleted that control rig a little bit too early. And I said control rig there, but I meant to say sequencer. So I'll go ahead and create that in this setup once more, and I'll cut the video and be back when I have that all ready to go. All right, here we go. A new pose here. And for this one, I'm mostly concerned with just demonstrating what we can do with this system. So I'm going to create a simple overlay pose that's different than our base pose. I think what I'll do here is make this character a hunchback. All right, so this I think should demonstrate the system well enough. So I will go ahead and add a keyframe into this here. And this time I'm going to shrink this animation down so that it's just a single frame. And I'm going to export this as an animation sequence. I'll toss it in the animations folder, ANOV, and I'll just say hunchback. Okay, back in our animations folder, I'm going to create a new folder here named overlay, and I'll toss both of these animation sequences into it. Back in our animation blueprint, I'm going to go ahead and hard code that overlay animation for the time being. We'll eventually have the capacity to blend between different overlays, but for now, I'm just going to use that hunchback animation to demonstrate how this system is going to work. So now we have our 3 input poses. And what we're going to really rely on here with this system is a node called Make Dynamic Additive. And for the base, I'm going to provide this base pose input, and we are going to be using these poses multiple times. So before we continue, I am going to save these poses. I'll name this one base pose, the second locomotion, and the third overlay. Now I'll go ahead and grab our base pose. I'll connect it into the base input of the Make Dynamic Additive node. And now I'm going to grab our locomotion pose. And now we've made the additive. And I'm going to tick this as a mesh space additive and create a new saved pose called post additive_ms for mesh space. And I'm going to copy this setup here and make a new pose here. And instead of mesh space is LS for local space. And I'm going to uncheck the mesh space additive option. And so what is the difference between mesh space and local space? Well, I do actually have a video that goes into the subject in much more detail, and I'll put it up in the corner somewhere around here. However, the quick version is that a local space additive applies in a bone's own transform space. So the bones all are aligned in different ways. And so if I apply, let's say, a 15-degree, I think it's Z-axis rotation on the lower arm bone, it'll rotate towards the upper arm, and it won't rotate around in any weird way it's not supposed to. But if I apply that on the X-axis in mesh space, it's going to apply that relative to the root. And so it's not just going to rotate on the bone's individual axis. So mesh space is useful in some cases, and local space is useful in some cases, and we're going to be making use of both of these additives. And I think we'll be using local space on the arms and mesh space on the spine. So we have our additives. Now, how do we apply them? That is the next step. We're going to get an apply additive node. For the base, we are going to input our overlay pose. And for the additive, I'm going to grab our post additive for mesh space, and I'm also going to get our post additive for local space. And I do think I made a mistake naming these. I named these post additive, but they should just be additive. So additive mesh space and additive local space. So we're going to apply the additive local space with the apply additive node. But to apply our mesh space pose, we need to make use of an apply mesh space additive node instead. And now I'm going to save two new poses. And these are going to be the post additive poses. I'm going to move all this down over to the left to move it out of our way. So now we have the poses that we need. Our post additives. I'm going to get a layered blend per bone node. Now, this is a very useful node, but it is not the cheapest node by any means, and you do not want to use too many of these. I tried to limit the amount of these nodes that I employ in this system, but I still ended up using 3 of them. And there are a few other instances in this system where I've made use of this node. And when I say this system, I'm referring to the entire Locomotion system that we've been putting together in this series thus far. Now, it was improved by, I think the number was 13% in 5.4 when Epic changed one line of code, but still, it is not a cheap node, and you want to be conscious of when and where you use it, because stacking these can and will likely impact performance to some degree. So for the base pose, I'm going to bring in our Locomotion pose. And I'm going to add an additional blend pose pin. Next, I'm going to get our post additive poses for mesh space and local space. I'll plug the mesh space into blend pose 0 and the local space into blend pose 1. And now clicking into the layered blend per node, layered blend per bone node, we can set up our layers. So we have 2 indices in an array here, and these indices correspond with our blend pose input pins. So index 0 corresponds with blend poses 0, and index 1 corresponds with blend poses 1. So For our mesh space additive, I'm going to add an item to our branch filters array. And the way that a branch filter works is that if I supply a bone name, in this case I will supply pelvis, we can blend onto that bone. And if blended depth is set to 0, we will blend to all the children of that bone. Now, I used to think that setting blend depth to a positive number like 1, in this case, would mean that we blend onto the pelvis and onto the bone spine 1. However, I've observed that it seems to have some other effect that I can't exactly pin down, and that it seems to affect, as far as I can observe, the amount of underlying base pose motion that gets blended in, and how that gets blended, I'm really not sure. If anyone does have the answer, definitely please let me know, as I would love to better understand this blend depth value, as it doesn't really explain much if I hover over it. The other thing we can do with this is supply a -1, and that will exclude this bone and its children from blending. So I'm going to leave this as 0 on the pelvis, but as we know, the pelvis is the root weighted bone. It's still a child of the root, but as far as all the other bones that actually control the mesh are concerned, the pelvis sits at the base of everything. So if we blend onto the pelvis and its children, we blend onto the entire skeletal mesh. And what we want to do is blend onto the spine and head for this mesh space additive pose. So I'm going to add 4 more indices onto this first branch filter array. I'm going to add one for each clavicle. So clavicle _R and clavicle _L. And I'm also going to do the same for the right thigh and the left thigh. And now I'm going to give each of these a value of -1. Next, for the local space additive pose, I'm also going to add some branch filters, 2 of them. I'm going to add one for clavicle right and one for clavicle left. Now, I'm going to go ahead and compile this. And as we can see, an overlay is being applied here. The character is standing with a hunched back. And there's some more work we'll need to do here. This is not perfect, and there's going to be more we're going to have to add into this system. However, I do want to go ahead and show you guys the result of what we've done thus far. So I'm going to go ahead and save everything we have here and play. And now, as you can see, the character is hunched over. That additive pose, that additive overlay is being applied to absolutely everything we're doing. Walking, running. And so this is really fantastic for changing the posture of a character. So the underlying way that the character is standing while moving around. And of course, it does look a bit strange. These, athletic, quick motions, pivots where we're making large leans, where the character is just standing with a hunched back. We might have wanted to do something a bit more subtle. A great example is the Advanced Locomotion System version 4, where there's a masculine pose where the arms are held wider and a feminine pose where the arms are rotated back in a bit. Always want our character to have a hunchback, and what if we want more control over our character and how this system works? What I'm going to do now is add another layer. In this one, I'm going to name Overlay Layers. I'm going to open the content browser and I'm going to create a new enumerator. And I'm going to name it Overlay Layers. I'm going to fix that typo. I'm going to add 2 enumerators. Base and the one overlay that we've created so far, hunchback. I'll save and close out of that. And now, inside this animation layer, I'll get a blend by our overlay layers enumerator. I'll right click and I'll add our hunchback pose. This default pose is always going to be the first enumerator in the whole thing, so that will be our base pose. And now, back in our Enum graph, I'm going to grab this hunchback, cut it, and drag in our new overlay layers animation layer and plug that in. I'll paste our hunchback in, and I'll also get our base pose overlay. Finally, I'm going to add a variable to our system, and I'm going to name it overlay layer. I'll go ahead and set its type to be our new overlay layer enumerator, and I'll drag that in. Blend time will probably be best at something around 0.2, so I will set those values accordingly here. And I'll go ahead and set this to be an inertialized blend, as I think that might look a bit better. So now we need to set our overlay layer, and we are going to do that in our third person character, because there may be other things we want to do with this overlay, such as when we equip weapons. Now, in a full game, we'll probably would want a separate inventory system that handles equipping weapons. But for now, because we're mainly focusing on locomotion in this series, I'm just going to focus on updating these outside system values from our character blueprint to keep things simple, yet we can apply the same principles in larger, more complete and proper systems, though you, of course, can implement these connections to the animation blueprint where you send the data in your own systems that you're using in your game. So, we've previously made use of a interface, and so we're going to continue to use this interface, the character data interface. We have a receive gate data and a receive ground distance function here. I'm going to add a new one named receive overlay state, and it's going to have an input of that same enumerator type, and I will name it overlay, if I can type correctly. There we go. So now, let's just go ahead and hard code a switch. I'll get to the F key pressed button. So I'll just search F key and grab this node here. And when it is pressed, we're going to get our mesh, and from our mesh, get our animation instance. And that's the incorrect node. There we go, get Enum instance. And from our Enum instance, I'm going to call that interface function receive overlay state. So if our animation instance implements this interface, it'll call this function from within our animation instance. So I'll just say pressed, our overlay is base, and released, our overlay is hunchback. We can now find our interface function in our animation blueprint, and that is because if I click into class settings, we have it selected in our implemented interfaces from an earlier video. And we just do that through that add drop-down menu right there. So now we'll just set our overlay layer variable from that overlay input for our interface function. And now if I play, we're using our base pose, but if I hold the F key, I think I did something backwards on accident, guys. I apologize. If it's pressed, we should be hunchback, and if it's released, we should use our normal base locomotion. So now if I play and press this, we adopt the hunchback posture. If I release, we go back to normal. Now back in our overlay blending layer, what if we only want to apply our additive to part of the character and not the full upper body? Additionally, we have not applied anything to the legs either. Well, that's just going to be a matter of adding more blend poses on. Right now, we blend local space onto the arms and mesh space onto everything else. And now this is going to be totally up to you when it comes to how much control you want over the application of additives. So what I'm going to do is just show you the fullest, most in-depth application that we could come up with for this system by being able to blend onto the spine and each arm and each leg individually. Actually, let's do the spine, each arm, and also both legs together. Each leg individually might be taking things a tiny bit too far. So I'm going to go ahead and add 2 more input pins onto this here. And I'm going to duplicate this mesh space once and this local space once. So I'll plug the local space into one and the mesh space into the other. And so on our first local space where we have both the clavicle right and clavicle left, I'm going to delete the clavicle left. And on the second local space that we just added, I'm going to add clavicle underscore L, or our left clavicle. And on the final one that we plugged our mesh space into, I am going to add our thigh right and our thigh left bones. Now, I am doing mesh space for the legs because that will help to preserve the proper positioning of the feet. However, mesh space doesn't account for local bone orientation, so you'll want to make sure that you don't rotate the legs in or out in your overlay poses, or the knee will bend at a bad, impossible angle. And that is unfortunately a drawback of the way the system is put together currently, but overall most of this overlay blending should be occurring on the upper body as opposed to the lower body, as a general rule of thumb to keep in mind. Now we have blend weight float inputs that previously were just always set to 1, but we can now actually read from animation curves. So let's go ahead and grab some get curve value functions. And I'm just going to go ahead and use a naming convention of OVR for overlay. Actually, let's do OVL for overlay underscore, and I'll do arm underscore R. Copy and paste arm underscore L. Copy and paste. And we'll do legs instead of arm. And we need one more actually. And we need spine. So let's do spine. I'll now plug each of these in. And what we'll see here is that if I compile and play, nothing happens when I hold down the F key because there are no curves in the overlay animation to tell Unreal to blend. So now I'll go ahead and make my way over into our animations folder and into our overlay folder and onto this hunchback animation. And I'll add a curve. I'll create a curve and give it the name OVL underscore arm underscore L. And I'll add a single key to this curve and set it to 1. And now if I play and hold the F key, I'm not seeing that much of a difference. Okay, this is actually a great opportunity. So why didn't that work? It's because I forgot a pretty important step, but it's also a really difficult step to figure out in the first place, and I would have maybe given up if I hadn't seen the implementation from the advanced locomotion system. And, well, why isn't that overlay occurring? Well, that's because we're putting in this locomotion pose, and we're reading the curves from the pose that are contributing to the output pose of the main animation graph. So the animation graph, the way it works backward from our final output, figures out, well, what animations, what nodes are contributing, and looks at those curve values. And, well, these poses here, they're only contributing if they have a curve value, and we're holding the curve value in the pose, so they'll never contribute. How do we fix that? We add a second layered blend per bone node. And this is a bit sneaky. We don't add any branch filters. We don't blend anything from the second blend pose, but we supply our overlay pose. So now Unreal's going to look at this and say, look, the blend weight is 1. We are using this overlay pose. It's contributing. We need to look at all the curves here. It's not going to affect the actual pose output, but it is going to force the engine to always read the curves present in the animations being played from our overlay layer animation layer, where we have input creating this overlay pose inside of our blending layer. So now if I play, hold F, and it changes that arm to match. And that hunchback animation isn't really the great example. The main point is not that arm, but we could do other curves, other animations. That's how all of that works. So it's super versatile. I'll go ahead and open up this and add some more curves in. We'll create a curve OVL underscore arm underscore R. And finally add a curve OVL underscore spine. So finally, I am going to add a key right here for the spine and for the right arm. And all these keys and all these curves are just going to be set to a value of 1. So now if we play, hold down F, we apply the full overlay pose. And so that is a basic additive overlay system, everyone. In the next video, we're going to start on our override system, which will be an extension of the overlay system built inside of the same animation layer, the same node group, to be able to override the right arm or the left arm or both and have one follow the other. And we'll facilitate all of that along with hand IK and virtual bones in the next video. And I may split it up into 2. We'll see how that goes. But that is where I'm going to end out this video, everyone. And I do actually have the full project files for this completed overlay system and locomotion system available on my Patreon, where you can access all the project files for my tutorial videos for $10 a month if you would like to support me. You can also get videos a week ahead of release on YouTube there as well. And I do need to give a shout out to all of those supporters on Patreon to thank them for their continued support. So thank you guys, and I'll see you all in the next video.